HTML uses what are called elements to structure content in a web document. These elements can be created in any text editor. The elements act as instructions to the browser as how to format the content. Browsers are designed to recognize the elements included in the document and will attempt to display the content as intended. Elements say things like, make this text the main heading, make this text a paragraph, make this text bold, make a list out of this content, display this content in a table. And no matter how complex and sophisticated today's web applications are, at the heart of, say, Facebook and YouTube lies this simple structure. So what does an element look like? Well, an element generally consists of an opening tag, which is made up of some characters wrapped inside angle brackets, followed by the text to be structured, known as the content, and a closing tag, which looks just like the opening tag, but has a / inside the angle brackets. In our example, we are shown an element that is used to display text as something important. For example, in a newspaper, this would be the headline. In a research document or a blog post, this would be the title. The H1 characters inside the angle brackets of the opening tag say to the browser, until you're told otherwise, all content after my right-hand angle bracket is to be displayed in big bold text. The browser says, OK, and prepares to display the content as big and bold. As the browser reads the content from left to right, it will eventually come across the closing tag. This closing tag says to the browser, we're done here. No more big and bold text required in this element. The browser will continue scanning any other elements in the document until it sees a special closing tag. Elements can contain text, but they can also contain other elements. In the example shown here, we would say the paragraph element contains the emphasis element. Or we can say that the emphasis element is a child of the paragraph element. People refer to this as child-parent relationships or nested relationships. Any element that contains another element is said to be the parent of other elements. Those contained elements are called its children. These elements form a tree structure like a family tree. Languages like CSS, JavaScript can access and manipulate this structure to create dynamic and interactive content. A minimal HTML document can be created out of the fragment we've just seen by adding 3 necessary elements and a title. The first necessary element is the HTML element. This is the parent of all other elements. We recognize this due to it being the outermost element in the nested structure. The HTML element contains 2 necessary immediate children, namely the head element and the body element. The body element generally contains tags that are used to display content on the screen. The head element contains tags that provide supporting information, such as the page title. The page title is displayed not in the main browser viewing window, but in a browser tab. In addition to the required HTML, body, and head elements, there are a few elements that show up nearly in every web page created. For example, the paragraph element is one of the most commonly used elements. And as you might guess, it defines a paragraph. As with print media, a paragraph creates space above and below it to visually separate it from other content. Paragraphs and headings work in concert to create the majority of text content on a web page. HTML has 6 heading elements, which are numbered 1 through 6. H1 is the most significant and usually contains the title of the content. H2 represents a section, while H3 and so on represent identifiers for further subsections. The image tag is used to display an image on a page. Another common textual feature is a list. Lists can be divided into 2 types, unordered and ordered. Unordered lists display as bullet points. The order of the bullet points is deemed unimportant. An example might be the list of ingredients on a recipe. However, the order of the recipe preparation steps usually matters, so we would use an ordered list to represent these instructions. Now you'll explore these HTML elements and more throughout the challenges. But before we do that, we need to take a look at how we write and run our code, and that's coming next. Welcome to day 3 of your 5-day coding challenge. Today you'll use the extent of your knowledge of HTML and CSS in a practical way by beginning work on a recipe website that will progressively allow you to show off your newfound skills. But before we get to that, we'll talk a little bit about how modern HTML can be smarter. And as usual, we'll introduce you to some key concepts before you dive into your challenges. So be curious, get stuck in and enjoy. Semantics is related to syntax. Syntax describes how you say something, and semantics describes the meaning behind what was said. The original set of HTML tags were very generic in terms of semantics. For example, the paragraph tag describes a generic block of text, but nothing really beyond that. Now, as a human, you can infer the meaning of the content by reading the paragraph in the context of maybe any other paragraphs on the page, or maybe the page title and any images present. The browser and search engines, however, can't easily do that. Search engines can look for keywords on a page to try and glean some meaning, but the keywords found may not reflect the main purpose of the page. Those words might be located in a page footer or a sidebar and be unrelated to the main content of the page. In other words, while the syntax may be clear, the semantics may not be. The latest incarnation of HTML, called HTML5, attempts to address the absence of semantic clarity in older HTML elements. In doing so, it has introduced what are called semantic elements. These elements clearly describe their meaning to both developers and browsers. By the way, HTML doesn't do away with the older elements, it just introduces additional elements to supplement and add context to their meaning. Here's a list of more common elements. Header. The header element provides introductory content. A header typically contains a group of introductory or navigational aids. Where would you use this? Well, the obvious place to start would be at the beginning of your page. A header typically contains at least, but not restricted to, one heading tag, H1 to H6 say. Although you can use multiple headers on a page, one such place may be inside an article. The nav element represents a location on a page, and that links to other pages or to parts within a page. It's like a section with navigation links. Note though that not all groups of links on a page need to be in a nav element. Only sections that consist of major navigation blocks are appropriate for the nav element. The article element represents an independent piece of content. That is, content that makes sense on its own. This could be a blog post, a magazine or a newspaper article, a user-submitted comment, an interactive widget, or any other independent item of content. The content of an article could be distributed and understood outside the context of the page. The section element is used to represent a group of related content. This is similar to the purpose of an article element, with the main difference being that the content within a section element doesn't necessarily need to make sense out of the context of that page. A website's homepage could be split into sections for an introduction, news items, and contact information. Sections could define a newspaper's section summaries and links to sports, current affairs, lifestyle, politics, and arts reviews. Now, there are many other semantic elements introduced in HTML5, and also some semantic elements that have been around for quite a while, such as the table and form elements. Why should you care about semantic elements? First of all, semantic elements increase the accessibility of your content. That is, they provide more meaning to screen readers used by visually impaired users. Most government-based project contracts require a high level of accessibility on their sites and web applications. Search engines also like semantic markup. Google no longer bases its search criteria on keywords alone. It bases them on intent. Semantic elements highlight intent. Online recipe for tea. And included in this recipe will be a title, an image of somebody really enjoying a cup of tea, a description of the benefits of tea and why you should drink it. And beneath that we'll have two sections, one for the ingredients and one for preparation. And when you hover over these sections, there is a bit of interactivity with some icons, just for fun. And at the bottom of this recipe, we'll have a footer and some copyright information. You'll notice that the difference between the ingredients section and the preparation section is one is a bulleted list and the other one is an ordered list. You can list the ingredients in any order you want, but the preparation generally follows a sequence of steps. So in terms of HTML, we'll have a header, we'll use an image, we'll use a paragraph, we'll use a subheading and another subheading, we'll use an unordered list, and we'll use an ordered list. We'll also style our recipe in such a way that it's responsive. In other words, it responds to the device on which it is being displayed. So the image will be reduced in size, as will the margins, the left and right margins, down the side of the text. The title will also be reduced in size in order to fit the mobile device. But the reason we're building this is to illustrate core HTML elements, core CSS, some basic JavaScript, and responsive design. HTML structure in place. And the editor we're using for this is Replit, the excellent online browser-based editor that we use across all our fundamental series of modules. So we're going to break it into a header and a number of sections and a footer. And each of these elements or entities will represent sections on our recipe. So for example, the header will contain a recipe name, the image, and the description. And for now, we'll just put words inside here. We'll just type in words as placeholders for where these more complex structures will eventually be inserted. So our first element is a header, and it'll contain the recipe, name, image, and description. Then we have a section, which will contain our ingredients heading and our ingredients list. We'll then add a second section, which will have the preparation header and the list of steps required to make a cup of tea. And just to repeat, this is just placeholder text that will be replaced by the actual elements themselves. But by doing this, it gives you a visual clue and indicator as to what needs to go where. So finally, we add a footer, which will contain some copyright material. So you can see we have a header, we have two sections, and we have a footer. Let's take a quick look at our finished project. There's our header, which will contain an image and our paragraph. There it is there. There's our ingredients with the header and the ingredients list. And we have our preparation header, subheading, and the preparation steps. And finally, we have our footer with the copyright text there. I'm going to name this project How to Make Tea. The view of this project will look slightly different from the challenges that you'll undertake here as well, because the project-based view of the editor looks slightly different from the challenges, but essentially it's the same functionality. So there we see the results of running this. You notice that all of the contents within these headers and sections the text always appears on the same line, because that's what happens by default with HTML, unless you specify certain element types such as paragraphs and headings and so on. Now we have our core HTML functionality in place with some placeholder text, and we'll build upon this throughout the remaining lessons. Add some more basic elements. So we're going to add our page title, which is a top level heading, H1, and we're going to call it How to Make Tea. We're then going to add two additional headings, H2, which is a slightly smaller heading than H1. So the headings range in sequence from H1 to H6, where H1 is the largest text, the largest font size, and H6 is the smallest. In general, we use H1, H2, and H3. So we're replacing our placeholder text with the actual headings at this point. Let's run to test our code. And there you see it. So we have our title, which is our lesson, our recipe. And we have our ingredients and preparation section headings. In order to focus on the HTML as opposed to the text, we're going to copy and paste text content in places where it's required. So we created a paragraph element and added the paragraph text, and that gives us our description of the recipe. Now that we have these in place, let's create our lists. So our first list is the ingredients list, and it's an unordered list. And this kind of list is represented by the UL tag, U for unordered, L for list. And we use this because of our ingredients can be listed in any order. And each list contains a list item. So we use the li element for each list item. Now in this case, because the list items are short, we'll type them out. And also to give you an idea of how the list items are created. Notice that the list items are contained within the UL, the opening, and the UL, the closing UL tag. The closing UL tag is represented by a /. So the unordered list contains list items. So currently we have a tea bag, we have water, we have milk, plant-based or dairy, optional, both optional, and we have, as our final list item, we have sugar or honey, both optional. So notice that our unordered list contains a number of list items. You could say that the list items are child elements of the unordered list, and the unordered list is the parent element of the list items. So there we see it. Now for our preparation, we're going to use an ordered list represented by the OL tag, O for ordered, U for unordered. By specifying that, we will by default get a numbered set of list items as part of the list. And again, just as with the unordered list, an ordered list contains list items. Now in this case, because the preparation steps they're more verbose, more wordy, we'll just paste these in rather than lose focus and waste time typing them out on the screen. Again, you can see that the parent list, in this case an ordered list, contains child list elements. This parent-child relationship permeates HTML. It's the secret to its success. And it also is the secret to the success of CSS styling. Targeting styles. In many cases, if you target a parent element with a style, the child elements will also pick up those styles. So we're still adding the list items for the unordered list. Notice the syntax for these. In the majority of cases, an element has an opening tag and a closing tag. The OL has a closing tag, opening tag, and it has a closing tag, which is the /OL. And the / in an element indicates the closing tag. It's the same with list items, it's the same with sections and footers. So the shape of these is quite consistent. And this structure has been the secret to the success of HTML when it was first used in 1991. It's its simplicity that allowed it to become so popular. There's our list items, our ordered list, and our unordered list. So the ordered list is our preparation, and the unordered list is our ingredients. Again, back to our finished project, you can see we're getting closer. So with each step, we're incrementally building our way towards a successful recipe page. Day coding challenge. Today, you'll continue your work on your recipe website. You'll add a recipe image to make your site look more appealing, and you'll also begin to modify your work to make sure your site looks as good on a desktop device as it does on a mobile. And as usual, we'll introduce some key concepts to you before you dive into your challenges. So be curious, get stuck in, and enjoy. Responsive design is the process of building a website that will automatically adjust and adapt to the screen size of whatever device the user is on. Current websites must have the ability to optimize the screen size of a device, whether it is a desktop, a laptop, a tablet, or a mobile phone. As screen sizes become smaller, content starts to take up more vertical space, and anything wider than, say, a desktop screen is usually pushed down when viewed on smaller devices. It's called flow. The viewport can be a desktop, mobile screen, or anything in between. So we need units that are flexible and work everywhere. That's where relative units like percentages come in handy. For example, setting an image to 600 pixels wide will result in it being too big to be shown properly on a smartphone screen. But setting the image to be, say, 50% means it will always take half the screen no matter what device it is displayed on. Breakpoints allow the layout to change at predefined points. For example, you might have 4 columns of content visible on a desktop or laptop, but only 1 column displayed on a mobile device. Breakpoints in responsive web design are browser widths that have what are called media query declarations. And these change the layout once the browser is within a defined range. Once a breakpoint, or browser width, is reached, we can activate a set of styles that are targeted for that particular window size. Sometimes it's practical that content takes up the whole width of a screen, like on a mobile device. But having the same content stretching to the whole width of, say, your TV screen often makes less sense. This is why min and max values help. For example, having a width of 100% combined with a max width of 1000 pixels would mean the content will fill the screen up to a width of 1000 pixels.